All right, everyone. Welcome to our last lesson of the semester. We will have our exam number 4 on Wednesday, so keep an eye out for that. Everyone will take it. Dual credit and non-dual credit students will take exam number 4 on Wednesday, so I will have information about that in the module. We will have no more class after exam number 4, so juniors, we will not be having any more class next Friday or next week at all. I will send an email out in the next week or so to everyone for dual credit, where to get transcripts sent if you need anything sent to your college that you're going to, or if you have any information that you need to get from UMKC, where to get that from, and kind of how to finish up the billing and such. And then if you guys have any questions, email me anytime, tstarks@gvr5.net. Congratulations, seniors. I hope that we have a graduation in person, so I will see you there, hopefully. Juniors, don't be a stranger next year. And I think I actually have some of you again in our new dual credit class we're offering next semester. So congratulations, everyone. Thanks for working through this incredibly crazy time, but I'm proud of you all. And like I said, don't be a stranger. Come say hi next year if you can. All right, just to finish off our rationals here, we're going to do a few review problems like elementary school versions. So this first problem here on the left, we have 1/2 plus 3/2. So something to think about, or something to remember when you're adding or subtracting fractions, you must first have a common denominator. Okay, in this case we do. So once we have a common denominator, you just add or subtract across the top. Okay, so in this case, 1 plus 3 would give us 4, and then the denominator stays the same. So 4/2, which in this case, 4/2 is 2. Okay, on the second example here, we do not have a common denominator. So what we have to do is we have to multiply both the numerator and the denominator by a number so that the denominators become the same. So in this case, our common denominator will be 6 because 3 does multiply into 6. So you have to ask yourself, what do I need to multiply 3 by to get 6 so that it is common? And in this case, that would be 2. But if you're ever multiplying part of a fraction, you have to multiply both parts to keep it balanced. So 2 times 2 on top would be 4. 2 times 3 would be 6. And we know that 4/6 is just an unreduced version of 2/3. And then minus that 1/6 that we had. Once we have our common denominator, we just add or subtract across the top. In this case, we are subtracting. So 4 minus 1 would be 3 over the common denominator of 6. And then always reduce your answer. 3/6 would be 1/2. Okay, and our last example here, the denominators are completely different, and 3 does not multiply into 5, and 5 does not multiply into 3. So the least common multiple, in other words, the number that both of those multiply into, would be 15. So we're basically just going to multiply them by each other. So I'm going to clear this off so we have a free space here. If I multiply this by 3 and this by 5, and then don't forget you have to multiply the top and the bottom of each fraction by that number. So on the left here we now have 10 over 15 plus, and then 4 times 3 would be 12 over 15. And then we can add straight across the numerators. So 10 plus 12 would be 22 over 15. That does not reduce, so that is my final answer. Okay, so those are kind of an example of each scenario we can have with the denominators. Okay, so we're going to apply that to, I'm going to skip this for a second, and I'll come back to this, but we're going to apply that to our polynomial versions. Okay, so here, this first example, I'll give you a second to write it down, or if you need to pause the video. So we have 4x over x minus 3 minus 2x minus 8 over x minus 3. Now in this case, the denominators are already the same. They're both x minus 3. Okay, so we can go straight to subtracting across the top. I like to put parentheses around these binomials because even though it's not there, they're assumed because that's the numerator of that fraction. It's grouped together by the numerator. So in this case, we have 4x minus that entire numerator is 2x minus 8. And that's a kind of a big deal because you have to subtract both parts of that numerator. Anytime you have more than one term after a minus sign, you have to subtract all of those parts. So what I like to do is just basically distribute this negative here, so minus 2x, and then subtracting a negative, we know, is adding. So that's what that numerator ends up being, all over the common denominator. And then obviously we can combine like terms. So I have 4x minus 2x would just be 2x plus 8 over x minus 3. Now you always need to simplify your fractions. So this is like that lesson we did this past Wednesday, simplifying rational expressions, which that's where we factored and then canceled like factors. So on the top, we can factor this. There's not much to do, but we can factor out a GCF. And if I divide these by 2, I get x plus 4, which in this case isn't going to help me because on bottom I have x minus 3. But sometimes when you factor that numerator, it'll cancel with the denominator. So like if this had been an x plus 4 on the bottom, those would have canceled out. But in this case, it's not. So you can just keep that as your answer. Okay. And then the other example we're going to do here, we're going to add. So I'll give you a second to write this down or pause the video if you need. So we have 1 over x squared plus 2x plus 1 plus 1 over x squared minus 1. Now, in order to more easily compare the denominators, we should factor them. They're much easier to compare when they're factored. Okay, so this first denominator would be x plus 1 times x plus 1. Adds up to 2 in the middle. And then this denominator over here, x squared minus 1, that's a difference of squares. So x plus 1, x minus 1. Okay, in order for these denominators to be the same, we have to multiply them by basically what they're missing. Okay, now this denominator on the right has an x minus 1 that the one on the left does not have. So I'm going to multiply that times x minus 1. And then remember, if you do it to the bottom, you also have to do it to the top. But now, this, here I'm going to erase this here, so go back, that's it, just x minus 1. Now the denominator on the left has 3 factors. The one on the right needs to match that. This one has 2 x plus 1s. So I need to multiply this denominator by another x plus 1. And if you do it on the bottom, you got to do it to the top as well. So now we have our common denominators that both have 3 factors. Okay? You can only multiply them to make them bigger. You can't just take something away. So that's why I had to multiply this one over here by an additional x plus 1. So now on top, x minus 1 times 1 is just x minus 1 all over, and then our common denominator is x minus 1. And I'm going to go ahead and simplify. X plus 1 times x plus 1 is just x plus 1 squared. That just makes it a little bit easier or shorter to write. Plus, and then 1 times x plus 1 is just x plus 1 over the common denominator of x minus 1 times x plus 1 squared. So finally, the denominators are common. So in this case, we can add the numerators. So I like to just write it all out, but you can probably do that in your head. So I have x minus 1 plus x plus 1. We just add straight across those numerators all over the common denominator. And then obviously, I'm going to kind of go backwards here. We have a couple x's we can combine. So x plus x would be 2x. But then negative 1 plus 1 cancels out. So all we have on top is that 2x with our common denominator. And there's nothing to factor on top. That does not simplify with anything in the denominator, so that is our answer. Okay, so that is how we add and subtract rational expressions, just like we did in elementary school when we add and subtracted fractions. Okay, now I'm going to go back here, and I'm kind of going out of order. I'm going to go back to these. This is our last thing for today. This is very, very basic. These are very basic rational equations. Okay, so just to kind of review what you did in probably Algebra 1, anytime you have a fraction equals a fraction, the way we solved it is by cross multiplying. Okay, so you just multiply this denominator by this numerator. So 3 times x would just be 3x, and then equals, and then you cross multiply the other way, so that numerator times that denominator would be 6. And then we just solve for x, so divide by 3, so x equals 2. Now that was pretty easy. We probably didn't even need to cross multiply there because it's pretty easy when these denominators are the exact same thing. It's pretty obvious that x needs to be 2, but you can kind of see why that works. Okay, so this one that's maybe not as obvious, we just cross multiply, and it doesn't matter which order you do it. You could do 3 times 7 first, so we got 21 equals 4 times x would be 4x. Then to solve by x, we just divide by 4. And if it doesn't simplify, you can just leave it as a fraction. So 21/4 would be our answer there. Obviously, that was not as obvious as the one on the left. Okay, so that was Algebra 1. Now I just want to kind of apply that to one that you'll probably see on the test. So this is pretty similar. It's not much harder at all. But on this, we just cross multiply. And just real quick, as you're writing it down, notice this little note. It says, assume that x cannot equal -2. That'll be important here in just a second, but you'll notice if x is -2, -2 plus 2 is 0, and that makes us have a denominator of 0, which we know that is undefined in math. That's not possible. So that's just kind of a side note. Assume that x cannot equal 2. So when we solve this, if we get x equals 2 as an answer, there's no solution because that wouldn't work. Okay. So let's go ahead and solve here. I'm going to cross multiply x times 5 first, so that would just be 5x equals, and then 4 times x plus 2, you're going to have to distribute that. So when I distribute this through, I get 4x plus 8 equals 5x. And then we just solve for x. So if I subtract this 4x over, that actually happens quite nicely because now I have x equals 8. And when I plug that back in, if I checked my answer here, if I plugged in x equals 8, I would get 8 over 8 plus 2 is 10. And 8/10 is equal to 4/5. That's the exact same decimal. In fact, 8/10 reduces to 4/5 if you divide the numerator and denominator by 2. So we had a good answer there. You can go ahead and circle it. X equals 8. And our last example for today, okay, we have another rational, or a fraction equals a fraction. Okay, so if I cross multiply, doesn't matter which way you go first. Let's do 15 times x plus 1. I'm just going to write it out first. Equals, and if you cross multiply the other way, and if I'm going too fast or you need a second to write this down, remember you can always pause it. X plus 3 times, that's a 3, times x plus 7. So on the left, we're going to need to distribute, so that'll be 15x plus 15. Now on the right side, a binomial times a binomial, we're going to have to FOIL this out. So x squared plus 7x plus 3x plus 21. And then we have on the left side, so we can go ahead and combine these here on the right. 7x plus, let's get our quadratic going here. So 7 plus 3x would be 10x. But we can obviously see here that this is a quadratic equation. So the way that we solve a quadratic equation is we get it set equal to 0, and then we factor if we can factor, or we use the quadratic formula if it does not factor. Okay, so let's get this set equal to 0. If I subtract my 15x's over, so that gives me x squared minus 5x. And then if we go ahead and subtract this 15 over as well, that would give us plus 6. And this one actually does factor quite nicely, so we don't need to use the quadratic formula. So the factors of 6 that add up to negative 5 would be negative 2 and negative 3. Negative 2 times negative 3 is positive 6, but they add up to be negative 5. So if we set these factors equal to 0, we get 2 and 3. But like I said with that last example, these types of questions you need to go back and check your answers, because it could be possible that one of these answers gives me a denominator of 0, which would be that would not work. Okay, so let's check. First, we got x equals 2. So if I go back and I plug 2 into either and really just need to check the denominators. So 2 plus 1, that's good. 2 plus 7, that's good. No 0 there. And the other answer we got was 3. So if I plug that in, we get 3 plus 1, 3 plus 7. Both of those work. Those don't cause any errors with the denominator. So those are good answers. You can go ahead and circle them. There's your answers. All right, that is all for your last lesson. Once again, congratulations. Make sure you read this module carefully and get ready for your exam on Wednesday. Thanks for watching.